Next is in another question on failure of distribution box in series. Solve it in a similar manner, but here is the question. Here is a supply, and there is a dB1, and this is the dB2, and this is your destination, and this one has a life of x1, and this one has a life of x2. Since these are connected in series, the life of the system, let's just say life of the system is z, and life of the system z is going to be the minimum of x1 and x2. So z is equal to the minimum of x1 and x2. So if we say that the CDF of z, if CDF of z is h of t is probability of z less than or equal to t. Now what we want to know is system survives. What this is representing is system surviving less than t amount of times, but it might be easier for us to calculate system surviving more than t time, which can be represented as 1 minus, or this whole thing can actually be represented as probability of 1 minus, or just say probability of 1 minus z more than t. So system surviving more than t times. This is system surviving more than t times, because this is less than t is what the CDF represents, the area to the left, but we are interested in system surviving more than t times. And system surviving more than t times is just going to be this is just going to be 1 minus x1 surviving more than t times and x2 surviving more than t times. So h of t is 1 minus probability of x1 more than t and x2 on probability of x2 more than t. This thing can be written as, this is nothing but, because this is the it can be written as 1 minus f1 t, because that will be the CDF of f1. CDF of f1 is going to be f1 t is going to be probability of x more than equal to t. So it can also be written as f1t is equal to 1 minus probability of x less than or less than or equal to 2 or more than t. So that's what this thing is. Probability of x more than t this whole thing is actually 1 minus, and that's where things starts getting very complicated. 1 minus, this is minus stays there, but this whole thing is also 1 minus f1t, because this thing is this. So probability of x1 more than t will be f1t or 1 minus f1t, and that comes here. Multiplied by, because these are all independent events, so they also get multiplied, 1 minus f2t. So that's your CDF of the system in series. Now once we have the CDF of this thing, now we want to know the PDF. What we want to know is h of t. To get to h of t, you have to differentiate this equation. What we want is dh over dt. So then you have to differentiate this whole thing, which is d over dt and inside this is just going to be this 1 minus now the d of dt of 1 is 0, so that goes away and you are left with a negative sign, d of d over dt of minus 1 minus f1t and 1 minus f2t. Okay, now it would be a little bit, we're going to use the same product rule, but it's so if you're going to use the product rule, we're going to do d over dt, we're going to stay this minus sign here, let's just do it this way, makes this more complex. So let's just call f1t for simplicity as, say, p, and call this thing as s. Okay, so we're going to write that here, p is equal to f1t and s is equal to f2t. So now it will become a little bit simpler to do this, d over dt minus 1 minus p 1 minus s. So when we are differentiating it, it will be minus, so product rule will apply, so this will be d over dt of, minus sign is over there already, so we don't have to worry about that, minus d of d over dt 1 minus p multiplied by 1 minus s plus, okay, d over dt of 1 minus s multiplied by 1 minus p. Okay,